Hello everyone, welcome to MRU E-Learning powered by Mallaradi University. Here we are going to be starting with your data structures and data structures with its operations, and it's one of the environment where we are going to be organizing the data to produce in the efficient usage of the developing the mobile applications and developing your web apps. This data we are going to be organizing. Now we are discussing about the complete organizing structure, that is your data which is available in the web. To utilize that, and we can able to make the different variations of the web applications and mobile applications which are used in the social media. Now this is presentation today going with Dr. P. Vinay Bhushan, Associate Professor, School of Mallaradi University, School of Engineering, Freshman Engineering Department, Department of Computer Science Engineering. Starting with your first slides contents. Today's session's contents, we are going to be discussing about definition of your data structure and categories of your data structures, operations on data structures, and after organizing your data structures with its operations, we are starting with your arrays versus your dynamic memory allocation and array data structures, array operations, and to its associated algorithms on the array operations. We are going to be discussing the contents. Now starting with your first one, data structures. The data structures mainly we are going to be using as user introductory part of the technical aspect. We are going to be taking the data to organize, to manipulate, and it can be used in many programming languages. It is not sophisticated to respective programming language. Either we can use with your C or C++ or Java or your Python. We can able to frame with your data structures. Now, these are not the way of your accessing and processing of the data, little easier, and you're more efficient in the utilization of your mobile applications. Coming to this all, the major role plays in the data structures is your data types. The data types are often confused as a type of your data structures, but it is precisely even not correct. Though they are referred to as an abstract data types, we are going to be taken with your ADT's environment. Abstract data types, we are going to be taken with the help of your primitive data types, which is you are categorized of integer, float, character, strings. They are the basic parts. Based on these basic parts, we are going to be taking the data structures specifically in the Python with the ADT's concepts we are going to be overusing. Now, overall of this introductory part of your data structures, we are having the definition of your data structure depends on your data types. This represents the nature of the data which we are going to be taken into the consideration for framing our data into that organizing the frame, while your data structures are just a collection of similar or different data types in one environment. This is your definition of your data structure is. Coming to the next. How we are going to be classifying the data structures based on your data which you are going to be organizing in the environment, where we are going to be designing a plenty variety of the web applications, mobile applications, in the social medias platforms. We are going to be taking the very different variants of the data we are going to be taken into the considerations. Based on your data which we are going to be taken into the considerations, the type of the data will decides the which type of the categories of your data structures we are able to use that. That is, mainly we have your two types of your data structures. Where is your linear type and your non-linear type. Linear type is one type where we are going to be taking the unorganized data, we are going to be organizing in the fashion, and then we are going to be using our further problem solutions. Whereas your non-linear, this is a variation where your unorganized data we are going to be taken into the consideration in unsorted fashion itself only, and make your some type of the algorithms are required your unsorted environment itself. There we require some sorted elements, sequential elements we does not require. Then we are going to be preferring with your non-linear fashion, non-organized data environments we are going to be using. Like that, seeing the classifications under your linear and non-linear, coming from the main structure of the data structures, we have your primitive type and your non-primitive type. Under the primitive type, we have the basic data types like your integer, float, characters, strings, Boolean types we are going to be taken into the primitive types. Whereas your non-primitive types, we are going to be seeing that the data structures main procedures, which is your linear fashion and your non-linear fashion environments. Again, in the linear, when you are going to be taken in the sequential data representations, the static data and your dynamic data are categorized into two. Where is your static? This is the meaning that where we are going to be taken your data as your giving the specification within the program itself, and then we are going to be running that and executing the programs. That is your statical declaration. That is your variable, the value we are specifying within the program, and then we are going to be compiling and executing the program. Whereas your dynamic is a one nature, where we are going to be giving the memory allocation for the variable, but the value we are going to be specifying for the variable at runtime environment. That is your dynamic nature. Like this, your static is categorized in your arrays of your one homogeneous data representation, and whereas your dynamic is we are going to be taking your first you are declaring the memory in the variable declaration within the program, then you are calling the value at your runtime environments. Such type of the elements we are going to be calling in your linked list, queues, and your stack environments. Coming to the non-linear fashion, we have the trees and your graphs environments. Trees are the tree and graph are required your unsorted list of the elements. They are unorganized data we are going to be taken into the non-linear fashion. Like that, your trees and graphs are going to be presides in your hierarchical fashion of your data representations. This is about your completely your types of your data structures. Coming to the next part, the operations of your data structures. Here we have your different operations we have performed to manipulate our data and in every data structures. Let us we are seeing in the previous categories like your arrays, linked list, stacks and queues, trees and your graphs. These operations which you are discussing in your data structures, these operations of the data manipulator we are going to be preceding in your further the operations like your traversing, insertion, deletion, searching, sorting, and your insertions. We are going to be performing this element organization fashion. Seeing with the first one, that is your traversing environment. Traversing a data structure means visiting all elements stored in it. Means we are going to be inserting some array of your elements or your list of the elements we are organized. It is in unsorted fashion. I want to be make that visit all elements which I have inserted into that array elements. I want to be visit each and every element. Then I want to be print that which element I are visited and which element has to be printed in your output screen. Like your traversing is one technique. It is to be print the systematic manner. The manner of the element association systematically, sequentially, we are going to be in the sequential order or unsequential order. In which fashion we require, in that fashion we are going to be inserting the elements. This technique we are going to be using for mainly for the purpose of your printing the elements, searching the elements, displaying the elements, and reading the elements in the data which you are stored in your data structures. Clear? Now seeing with your traversing procedure, it is one of the technique in your data structures to visiting the all elements. We have your one real-time environment example is there. That is your how we are going to be taking the data into the consideration, how it is going to be navigating to the websites which we are going to be creating. Means nothing but every web page I want to be create and I want to be visit that the client should be visiting the every web page to be visited and utilize the opportunity of what data we are going to be organized in the individual pages. They need to be show and they need to be look into that and then make the usage of the web page which we are created. Like that, every client is going to be visiting our web pages daily and daily. We get the frequential access of our website is more convenient to the client upon the usage. Like that, your some of the examples we have here, visiting the home page and your categories of that, what are the home page, the menu list we are created, and inside that what are the subcategories are there, and what are the products we want to be see that in the web page, we are going to be seeing that. The best example is your Amazon website. When you are created the Amazon website, product I want to buy with the product categories and product pages, and I can search with your product specifications, then I choose the product. The choosing the product is the best example for this traversing mechanism. Clear? This is the main meaning of your traversing. Now coming to the insertion. The insertion is that one operation where we are going to be adding the new elements to the existing list we are created or array elements we are created. Means adding a new element to the existing place. That is your best example for this. Nothing but we are taking the real world analogy of sorting a hand on playing the cards. Whenever the playing the cards, a real-time example I am taking here. Playing the cards, if it is an unorganized fashion, I want to be insert there from the first element to place it into the third element or your fourth position, like your indexing representations, like I can insert it and I can proceed with your example here. That is your playing cards to be arranging in your specific order. Now coming to the deletion, I want to be remove an element from the already listed element, which is I am not required to be print on the output stream. That is the best example is nothing but the playlist of your music. When you take the music playing on your application, one of the application, when you want to be, that is the music which I am not required to be playing the frequently. I want to remove from the list. Using the delete operation, I can delete very conveniently. Now coming to the next one, the fourth technique, we are with your searching. Inside that, I add binder with your sequential of elements I created inside. I want to be searched, but I can't able to find the index numbers where it is represented. I want to be find that my element is under the which index number and what is the element I am going to be searching. I know that indexing number, but the element I does not know. I want to search with the index representations. The best technique to be searching the element with the help of the indexing is searching operation. See. For the best example is nothing but dictionary. When I want to be searching a word in the dictionary, I can refer the page number, I can refer the keyword, and I can refer the page number. I can find out that this word which I am going to be searching, it's going to be best searching with your indexing representation. Like your best example I can taken here for the searching is looking up a word in the dictionary. Clear? Next with your sorting procedure is a sorting technique we are going to be calling. Sorting is nothing but it is used to arrange the elements in your particular independent procedure. I want to be order the elements, arrange the elements in particular fashion, either in the ascending order or in the descending order. In the unsorted list elements, I want to be keep in sequential access. When anyone want to be search the element in your sequential procedures, this after arranging that in the ascending order or descending order, then I can find that element very easily, conveniently. Right? In this, we have your sorting procedures. We have your plenty sub-algorithms are proceeded with your insertion sort, like your bubble sort, and your merge sort, and quick sort. These are the sorting procedures we are going to be discussing with the help of the algorithms with some real-time example in your next slides. The best example I choose for your sorting procedure is again your music stream application I am taken into the consideration. I want to be choose or your arrange that devotional songs as a one part and your romantic music at some part and some other category of the plays styles. I want to be make that in particular order environment. That I can done with your sorting environment very conveniently. Next coming to the merging. When I want to be combine the two data structures together, I can take the best choosing procedure is your merging operation in your data structures. See, one of the best example I taken here. I had a retail company, online retail company I had. In that, a company is storing the customer orders history in your separate files. But your all the customer IDs is a one complete common procedure in your customer order history. I can able to find that history with your every year details with your customer ID environment. Customer ID I can take as one of the primary key parameter like, and I can identify it like the orders of your 2023, orders of your 2024 are combined in the complete customer order histories. I can make the division and they can identify the customer IDs is the one key concept I am going to be keeping, and later on I can retrieve the data outside which I require is your customer ID. Like that, this is the merging is one of the best example to combine and extract the required data in the outcome. Now coming to that, these are the 6 operations of the data structures. Based on these operations, we are going to be applying into our categories of data structures like your arrays, linked list, stack, queues, trees, and graphs. In that, we are going to be performing these operations, taking the real world entity problem solutions into the nature, and we are going to be evaluating their algorithms, how they are going to be organizing our data structures. Now for the next, going to that completely into the nature of your arrays is the first data structures category under the static of your linear function. First, we'll discuss that how we are going to be allocating the memory in your normal arrays and your dynamic memory allocations, which is like your static representation, how your variables are declared, in the dynamic, how your variables are going to be declared, and how the variable associated values are going to be retrieving with their organized data into the output environment. Now, seeing with your arrays, how your memory is going to be fixed or flexible in nature. The arrays we are going to be, initial we are going to be calling it as a fixed size determination. It is in the compile time we are going to be calling. Whereas your dynamic is going to be calling at your runtime environment. Dynamic specifically we are going to be calling as your runtime environment. Here I call your arrays your compile time environment, that is your static representations. Dynamic is your dynamic nature. Your memory is going to be allocated in your runtime environment. This is your compile time environment. Like here the size is your fixed, and here the size is your varies based on your value declaring at a runtime environment. Yeah, there is a more differences we are going to be seeing. The foremost difference we are observing in your arrays versus your dynamic memory allocations. See, statics are nothing but we are going to be calling your variable to the value which are going to be declaring inside the program. Whenever we declare variable to the value inside the program, the statics are working very fast and you're simpler comparing to the dynamic memory allocations. Dynamics are nothing but we are going to be giving the space for the value to the variable at asking the value at your runtime, like your user input statements, like when you take the best example in your Python programming language when you're discussing. Clear? Now this is we are going to be calling as the main thing in your dynamic nature is fragmentations. The memory fragmentation. Initially we are going to be allocating, later on at runtime we are allocating the value to the variable. Now most probably we are going to be seeing the most differences comparing to the static representations and dynamic representations in the arrays and dynamic memory allocations that we are going to be seeing in this slide with your key differences and considerations. There is a first one, automatic memory management. That is your memories are declared automatically in the dynamic memory allocations in your C programming language. When you we are going to be taking the specific operations like your malloc we are going to be taken, calloc we are going to be taken, and free the memory we are going to be taken. In this, these are the three keywords we are going to be using for allocating the memory dynamically, that is your automatically, with the help of these keywords in your C and your C++. Whereas your Python, we are going to be taken with your new is a one operator we are going to be taken, delete is another operator we are going to be taken. These are the two operators we are going to be taken for your automatic memory allocations. Here, this is your automatic management. Flexibility, that is your size, the space which we are going to be allocating based on your C. Arrays are going to be having the flexibility in the size is fixed and the values are fixed. We can't able to change the environment of the once the array values to the variable we are going to be declared. That is also the syntax we are going to be discussing in the next syntax. Whereas your dynamic is nothing but flexible in the nature. Variable size we are going to be not specifying, empty space of the memory we are specifying, values we are calling at your runtime environment. That is we are going to be seeing in your flexibility in the nature of dynamic nature. The performance coming to the both are very faster in the nature to calculate your any problem solutions, but the sizes are going to be taken into the considerations. Some more comparing to the arrays is going to be giving the faster, and Python which is going to be taken with your new operator, it performs very fast in your allocation value to the variable. Whereas your heterogeneity and your homogeneity is nothing but your memory to the values are fixed or variable in the nature we are going to be calling is homogeneity, and your homogeneity is for the dynamic memory allocation, heterogeneity is for your array allocations. Coming to the next. See, we are seeing the differences between arrays and dynamic memory allocations. As we are the one of the linear fashion of the static, under that we are discussing about the array data structure. First, we will have the array, how the values to the variables are declared. Then how it is memory address is going to be allocating. What is its syntax with small example. Then we will go with the operations of the array data structures. First, discussing about your array implementations. See, we will see with your array on your differences, how the normal array and your dynamic memories are going to be created with their specific syntaxes we are seeing here. See, when I am taking in the Python into consideration, I am taking this data structures in the Python environment as they are taken for your importing the packages like your environment, importing the array. First, I want to be import the array. Why? Because array is a one model where to allocate the memory management automatically. I am taking your importing the array. Then array which is called as your my array is my variable name, and your first is equals to array is my module. Then dot with your reference point. I am taken with your array is your method name. Then followed by your I represents, that is your integer data type, followed by which category type of your elements you are going to be inserting inside. The type we are going to be declaring as your variable in the consideration, string like your declaration. That is your single quotes I stated with your I. I represents your integer type of the values I am going to be inserting, like your 1, 2, 3, 4, 5 elements I am going to be inserting is here. This is the syntax for your array representations in your Python specifically. Basically how it is declared, we'll discuss in your next slide. Coming to the dynamic nature, it is the variable name I am declared with your my list, and the size I am not going to be specifying, and values also I am not going to be specifying. The empty of your brackets I am declaring here with your square brackets. Whenever the square brackets are nothing but we are going to be having the memory allocation space. Further, we are going to be inserting some elements in that memory allocation spaces. Initially, we are giving the dynamic memory allocation over here. Now, stating with your reference to this my list, I am inserting your my list with one of the method in your array, Python. We are taken with your list environment. Append method, inserting element. Append method is nothing but inserting the new element to the existing list or an empty list. I am inserting here one element. One is a value I am going to be inserting into your my list with the help of your append method. Like that, whenever I am calling the append method, new element is going to be inserting inside and increasing the order of the elements. After once I given your empty declaration, then after I am going to be declaring one element after one element I am going to be inserting. Like the list will go upon your size also dynamically fixed in the nature. This is the common differences we observed in these two categories, arrays and your dynamic memory allocations. Now we'll see about your arrays. What is an array? Array is your type of your linear data structures. As we suggested, the data structure is one of the category of the static. Static we add with your array element. That is your defined as collection of elements of same or different data types. Just now we have seen with your array elements with integer type and followed by your sequence of all integer elements. See, array is a one procedure. We are fixed with the only integer type of elements. I can vary with your integer elements to the combination of the float and combination of the characters. I can bind it inside that. But that is going to be again calling it is into the Python with your list environment. It is possible. Now seeing with your, that is your single dimensionally I can also represent, like your one dimensional represent, and multi-dimensional also represent with your elements association. That is your two-dimensional, three-dimensional, multi-dimensional I can call it as. Similarly like your matrix representations. Now seeing with your syntax of your arrays, this is your basic structure. Earlier we have seen with your packages environment. Now we are going to be seeing with your basic structure of syntax with your array representations. First we'll start with your data type, then followed by your array name, then your brackets we are specifying for the purpose of your size of, means how many elements we are going to be calling, to that associated indexes are going to be calling. To associate the elements to the indexing point, here we are discussing about your array size. And how we are going to be calling the elements means the elements are going to be decided with equals to the flower bracket represented inside we are binded with your elements with your comma separated. Then we are closing with your flower brackets. Here see the example. Down we have, I am also given with your example also. Int is the data type and array is your variable name, that is your array name, and your size I given with your 4 size. Means indexing representation with 0 associated to 1, 1 associated to 2 associated to 3, 3 associated to 4. Like there are 4 elements I am taking, 3 indexes I am going to be represented. Like your 4 indexes, 4 values. Every index is defaultly start with your 0. See, I will show with your clear definition of how the memory is allocated and how the values are going to be associated to that normal indexing and memory indexing in your next slide. See, earlier I have taken with your different example. Now I have taken with your picture example representing your arrays, how the elements are going to be associated, how the indexes are represented, how the memory is going to be fixed in your memory locations. Now starting with your data type, array name is your ARR, and the size I taken is your square brackets is your 5. The elements I taken is your 12, 34, 68, 77 and 43. Inside that, I am taking with, whenever the elements are called here, with my array elements which are in the example I given in the syntaxes provided with your array. The 12, 20, 34, 68, 77 and your 43. To that associated, whenever I am going to be inserting the elements, automatically memory is going to be allocated with your default 0. Then your next one with your 1. That like that, 0 is associated to the 12. To that, memory is addressed in your RAM environment with 2391. We are not going to be fixing any memory addresses. The RAM is going to be allocating for the size and your data which you are going to be inserting inside that. Like that, your 1 is associated to the 34, its memory address is your 2392, 2 is associated to 68, to its memory address is 2393, and your value of your 77 associated with your memory index 3, and its memory address is 2394, and your 4 is going to be memory index value fixed for the 43, and its memory address is 2395. Like this, your memory address is going to be fixing automatically and your indexing is going to be fixing automatically when you are going to be allocating the values in the array declarations. Clear? That is the foremost we are going to be looking into the primary criteria whenever the array elements we are going to be binding statically. First, we need to look into that indexing representation. Start with your 0. And next one is your length of the array, the size of your array. We are going to be fixing in the elements. Then your memory address are automatically initiated for the value you are associated. This is a syntax for your array representation, which you are seeing in the array data structures. Next slide. Now starting with your algorithms on array operations. Now we are seeing with your array how the elements are associated, how the indexes are represented, how is represented with the static nature and your dynamic nature. Then further we are going to be on the top of the elements association, the data structures operations like your traversing, insertion, deletion, searching, sorting, merging. These are the operations are performing with the environment of the data structures and with some examples how they are going to be framing the algorithms for the array elements you are binded with. First, we'll see with your traversing technique. See, traversing already we discussed in your data structures. It is applied for all the elements in your assertion, in your list or your linked list to stacks and queues. Whereas in your traversing, in your array operations, all the elements are going to be visiting in your data structures is nothing but it means that you're visiting all the elements in the data structure at least once. Why? Because all element has to be printing your output screen. I'm not going to be skipping any elements. What are the elements I am going to be specifying in the array declaration? That all the elements has to be printed in your output screen. That's why the traversing will visit all the elements in your calling like your function calling like. It will call and it will print on your output screen. Like that we have your one of the example I taken here. You see, one of the variable name they have taken here LA. That is your linear array I am going to be calling. LA means the one of the variable name I am taking as your linear array here. Of your size is dynamically I am specifying. In the array dynamical also it is possible. Based on your value allocations, the sizes will be fixed at your runtime environment. The value I taken is here 1, 3, 5, 7, 8. I taken your 5 indexes with your 5 elements I am going to be fixing with your elements. Now see, consider LA is your one linear array and we have to be travel among all the elements starting from the lower boundary. 1 is your lower boundary and your 8 is your upper boundary. Visiting all the elements, I need to be start from the first from the lower boundary and I have to be complete up to the upper boundary. Calling with your not directly elements, it indexing representations 0, 1, 2, 3, 4. All the indexing numbers I am going to be calling and it is going to be printing up to that, visiting all the elements and printing up to the upper boundary from the lower boundary too. Further, this nature, I frame your algorithm in your traversing with your array elements associations. See, applying the array operations on each element on your linear array. Start from the first. Allocate your memory for your lower boundary with your indexing representation. Suppose your indexing here, I am representing like your set K. K is my indexing number. LB is your lower boundary starting from your value called your 1. That is I am performing in your step 1. Step 3. Step 2 is going to be repeat the step 3 and step 4 while k is less than or equals to upper boundary. Means less than or equals to, less than the value calling up to the upper the boundary. That is your indexing from your k, starting from the lesser the value to the upper the boundary of your indexing representation. Call the all elements I am calling with your step 2 environment. Next, visit the elements with your LA of k, linear array of your k. Linear array of your k is nothing but your k is your indexing representation. Calling the all indexes into the nature, calling the one by one, and printing all the elements in your output screen. That is the meaning for your step 3. How it is going to be calling one by one? By incrementing the counter. I am incrementing the size by 1. That is your k equals to k plus 1. Initially it is 0. 0 plus 1 I am going to be calling with your 1 indexing nature. Initially it will call your under indexing 0. 1 is the value is there, that will be printed on your output screen. Next, incrementing the counter of the 0 plus 1. 1 is going to be calling, that is your 3 is calling into the next sequence. Like that, incrementing the counter up to the end of the upper boundary, it is going to be calling to the step 2 from here to here. Yeah. Then after printing all the elements, it will exit from the loop. See, here in this algorithm, whenever we are discussing about the algorithm, how much time it is taken for the visiting the all the elements to be printing in the output screen, and dynamically or statically how much memory it is going to be calling upon the elements we are going to be associated. Here we are having your time complexity. N represents your number of elements. I am calling the one indexing after another indexing in your output. That your number of the elements I am calling at a time is one number. That is I am calling with your O of your N. That is your big O notation of N complexity. I am going to be specifying for the time complexity. And the space is nothing but memory is allocated also. One memory is allocated with your one value. One memory is allocated with your one value. One memory is allocated with your one value. Like your one after the one element is going to be calling in your output. One memory is allocated. That memory I am going to be calling in the output string. Like your space complexity I am going to be giving as your O of your one. That your time and space complexity both are going to be specifying on your calling the elements, how many numbers you are taken and how much space you are allocating for the kth values. This is about your completely the traversing procedure is. The technique is. Next we are starting with your second one. We have your insertion. Insertion we already discussed with your one after the another element we are going to be inserting to the already existing element. The indexing positions we are going to be pointing and starting inserting one after the another element. Same linear array I am taken, dynamic memory allocation I am taken. It started inserting one by one element. Like that here, stating with your algorithm of your insertion, we start with your n elements we are going to be taken. With the kth positions we are taken with your indexing representation in your linear array. And started with your start. Algorithm or every time algorithms are going to be proceeding with your stepwise declarations. How we are going to be starting and how we are going to be stopping, and in between all the steps are going to be under the process nature of the techniques which we are taken. The first one technique which we are done with the second one is insertion. In the insertion elements are going to be proceeding with. First I am going to be inserting the n number of elements mapping to the j variable and incrementing the in the value here. And checking with your condition the j is greater than or equals to 1 upon your insertion. Whenever the greater than or 1, I want to be trying to be inserting the first position or second position or third position, checking the position with your greater than the symbols and incrementing that one with your LA of your jth element. If it is not required in that position, I want to be check with your comparison with your previous element to the next element. Then I am going to be declaring with your j equals to j minus 1. Decrementing that one and printing the item which we are going to be inserting, that we are going to be positioning on the kth position which we are going to be. Suppose I want to be insert your 3 under the index number 1. Then I am going to be taken with your linear array of the kth position with your 1 indexing number starting with your 0, 1, 2, 3, 4 indexes. I want to insert your another index 1 with your new element is your 3. That is your item is equals to 3 and your k of your size we are going to be giving with your 1 here. Then you are stopping the procedure after your inserting. Here also one positioning I am going to be inserting the element, the number, the complexity I am giving for the time taken is your number onwards, and the space I am going to take in with your one space only, that is why I am going to be taking with your m complexity of 1. Next, coming to deletion operation. Deletion technique is a one particular location we are going to be identifying either from the starting or in the middle or the end. I want to be delete, I can delete it. But positioning is a very important upon your deleting the element. Either by increasing the element, calling into the end element I want to be delete. By increasing I can delete it, the indexing positions. If the starting means no need of your any increasing or your decreasing the nature, right? In the middle, I want to be delete the element, I need to decrease starting from the last element. Like that, increasing and decreasing is most required with your last element and your middle element are going to be used in your deletion operations. Same example I have taken with your linear array fashion of your kth position of your indexing representation, and we are taken with your j of your elements here, and you are repeating the steps to the 4 and 5, which is your incrementing that last element over to delete. I am going to be performing the incrementing operator with your 2 steps, step 4 and your step 5. And no sir, I want to be delete with your middle element means directly take with your n equals to n minus 1. The n minus 1 number of elements minus 1. I want to reach the 7 means n minus 1. That is your 8 minus, indexing taking. It's not taking with your elements directly. It positioning with 0, 1, 2, 3, 4 I am taken. Indexing decreasing. 4 minus 1 I am going to be performing. 3 indexing. 3 indexing is going to be deleting. Then after the deleting the third position of your indexing representation with your 7 element, I can stop the environment. Here also I am taken with your number of the elements I am going to be calling individually. That particular element I want to be delete. That's why the O of n time complexity is going to be introduced here. And next the space complexity is also one memory I am going to be pointing. Under your deletion operation, I am taking your space complexity of your one environment. This is your deletion technique is. Now the next technique is searching operation. Searching is one element which are going to be a group of array elements are there. I want to be find that one element with its indexing representations. Directly I can go with your indexing representation or the value also I can possible with your searching with your particular element. Here also same example, same nature of that algorithm procedure I have taken for your linear array with your sequence of elements, kth position of the values I am going to be specifying here. Now starting with your algorithm, start, j initially start with your default indexing is your 0. Here j I am taken with your indexing representations. They will allocate your k to the n, k to the j, and checking with your number of j is less than or less than n numbers. Finding that starting from the last element, we are going to be starting with your last element, we are going to be changing your greater than symbol, or your starting from we are going to be taken, we are taken with your less than or just symbol. LA is equals to the item. Whenever up to that element is going to be finded, we are going to be checking with your all the jth positions on your number of elements. Whenever the equal item is find, then it is going to be printing into the output screen by incrementing the counter. Incrementing the counter, we are going to be checking the which value or your which indexing number we are going to be positioning. That value will be printing on your output screen. Then item is formed, then we are going to be printing in the output, then you are going to be stopping the procedure. Like that here also one by one element we are going to be associating. On your searching with your one element to the another element we are going to be positioning here. That is your number of elements we are going to be calling. We are not calling the all elements together, one after the another element we are going to be positioning, then the number is going to be printing here. And the time complexity is space complexity is taken here is nothing but your one element when you search, one element is going to be printing on your output screen. That is your O of your one space complexity we are going to be taken for the searching operations. Now coming to the next one, sorting. Your sorting is nothing but your arranging the elements in a particular order. Either we are taking with your array elements or your list elements, but we ought to be organized in a particular fashion. Either in the ascending order or descending order, or directly, sir, I does not require any ascending order or descending order. The fashion how unsorted elements are listed, elements are created, in the same fashion, I want to print, but it should be in a specific intended order to be called in the particular problem solutions. Then I can take the best choose with your sorting procedure is. Sorting is does not have its own algorithm. Its categories are going to be describing its specific algorithms. Here we have your 4 common sorting algorithms are there, which is we call as your bubble sort, selection sort, insertion sort, and your merge sort. Starting with your first bubble sort. Is a bubble sort is a one technique where we are going to be taken with a, like your water bubbles, every element is going to be identified under that. This element is exactly chosen for the particular problem solutions. Like the selection sort, same like your selection algorithm which we have taken for the technique of the array operation, same procedure we are going to be selecting the particular element in your list element, like you're finding like. Next you're inserting, like you're same inserting the elements in your already existing list. I want to insert with your new list element, then you can take with your insertion sort elements. Same like your insertion algorithm only. And met sort is nothing but your combining and your dividing conquer method is the best another technique we are going to be applying in the merge sort, where the group of items are going to be categorized specifically. Subcategories we are going to be dividing, and main category all the grouped elements we are going to be inserting inside. Now starting with your first one, we'll start with your bubble sort. See, bubble sort is your sorting method, compares with your two adjacent elements and swaps with your until that we are going to be looking for the intended order. Means it is going to be searching that beside the element which is exactly suitable in the order or not. Then it is suit, it will print. If not, it is going to be going to the next iteration process. That is your bubble sort. Same like your just a moment like your air bubbles in the water to rise up the surface. Each element of the array move to the end of your each iteration. Means until the iteration is found. Until that exactly suitable element to the adjacent it is found, it is going on checking the comparison and swapping the element. If not the match, it is does not going to be swapping. List will be as it is, going on with your next element into the communications. That is called your bubble sort is. See, here we have your small example I taken for your bubble sort to make the exactly choose of the elements which we are going to be associated. See, here step I started with your first iteration on your indexing 0. I add with your elements of -2, 45, 0, 11 and your 9. We have your group of elements are there. If these group of elements are exactly I am going to be looking, I don't need of your any bubble sorting. But I want to be intention that making the swapping procedure exactly matching that, making that algorithm into the procedure, I am going to be associating the elements here. See what algorithm I am framing here. Bubble sort of array, which is the array elements we are created here, like your -2, 45, 0, 11 and your -9 I taken. These elements I am going to be taken. That is your I with your indexing start with your 0. I started with your I to 1 and upon to the size of your n-1. Means starting from your here up to the here, make the comparison of your elements here. How the comparison I am taking, see the step of your fourth one. If the left element is greater than your right element, see, checking with your two comparisons, -2 is greater than 45 or not? No. That is your -2 is your lesser than your right element of your 45. No swapping is required. This is the technique we are going to be applying into the bubble sort environment. Until the next iteration, 45 and your 0. Now 45 is greater than your 0 is there. Now swapping is done in your next iteration. See, 0 is exchanged into the first indexing, 45 is exchanged to the second indexing. Like that, it will check the each and every element which is your left element is greater than your right element. This is the main procedure we are going to be seeing in the association of the elements in your bubble sort. Like that, your every iteration is going to be checking here. See, 11 and 45. 45 is greater than your 11. That's why it is swapped with your in the next iteration. 45 and your 11 here. Similarly, -9 and your 45. Again, 45 is greater than your -9. That's why the -9 is going to be swapped its techniques to -9 to 45 environment. Like that, this is your, now proceeding of your elements are there to check the comparison. Then this will be the final element association for your bubble sort algorithm. Every element is going to be checked with your two comparisons. One element 2 and 45 are comparing at a time, one time with your following algorithm main meaning is. That's why its power of two elements are going to be, two number of elements are going to be associating under the exact 1 second of the time. That's why my complexity is your taken with your time complexity n square. That here 2n also we can write or n square we can also write. But your lastly, all elements are going to be taken with your one element only swapping with your initial element. That's why the space complexity is going to be exchanged with one element. That is your complexity we have taken with your space complexity 1 year. That is your bubble sort environment. Coming to the next one. See, we see it with your what are the one algorithm procedure of the bubble sort. To that associated a small Python program we are framed how the algorithm is going to be defined and how it is going to be associated with your program specifications. Now taken into the one of the Python program I taken for writing the bubble sort environment. Here I am defining with a one keyword and the variable I am taking your bubble sort of your array elements. And I am taking with your in the array how many elements are there, its size has to be specified first. That's why I am taking your length of the array. And calling the one by one element, I am taking the range function in your for loop with your in operator with your calling with your I declaration. Similarly, not only with your initial allocation, the next value also has to check with your comparison whether it is greater than the value or not to the initial value. For that, I am taken with your 0 starting with your index number to the next positioning of length of array of your I minus 1 I taken from the last indexing to the current indexing. And that I am going to be mapping into the J here. Now making the incrementing that one indexing to the next indexing and checking the comparison greater than or not. That is your initial indexing and your next indexing are going to be checking here with your J greater than or equals J plus 1. This is your bubble sorting technique we are going to be performing in your descending order fashion. But I want to be printing that output as your a statement I am writing your ascending order to sorted array. After the association is done, then you print your data elements. How we are going to be exchanging is done, the comparison is performed, but how the exchanging, the swapping procedure is done. That the swapping procedure I declare here with your three different variables allocation. Like initially I am taken with your temporary variable and initial array I am going to be taken with your array of your J inside of that. Then checking with your array of your J indexing by incrementing the next one. Two comparisons are going to be done in these positions. The incrementing is done, then the swapping will be done with your incrementing one with your temporary variable. If the swapping is done, initially whatever the data is there, that will be printing as it is. Then the swapping is done, this is going to be independent order is going to be exchanging with these 3 lines of the code. Then initial data after your exchanging, what is going to be done, that exchanging will be printing out from the initial data representations. Then your bubble sort of your data function will be called from your initial definitions in your output stream. Yeah, this is about your bubble sort environment. Coming to that next, selection sort. This is also one of the same procedure like you're selecting the element and making the exchanging and with smallest element to the largest element and swapping the procedure and printing on your, it may be the sorted order or your unsorted order elements will be printing on your output screen. But your main motto we are going to be checking in your each iteration is nothing but places the elements from the beginning to the sorted elements. Now taken with your selection sort. Selection sort with your array elements and its sizes are taken into both considerations. In your step 1. Step 2 we are taking with your sizes from the 0 to the number of the sizes pushing into the I variable. Pushing into the I variable, next set that minimum. What is the current minimum is there of your index in your I? Then next step I am going to take in with your incrementing that to the next positioning. What is there? See with your first step here in your output. We have your 20, 12, 10, 20, 12, 10, 15 and your 2 is there elements. But they are in your unsorted order list or your array elements. I want to make your comparison with smaller to the higher element. Means I am looking for the ascending order here. Ascending order of the fashion of the elements want to be associated finally in the output screen. Next, comparison checking with this statement. Whether the initial element is your less than or greater than. Greater than is there. I need to be less than is there. I need to be swap the exchange. No need of that. Then the next iteration. See that. First iteration is not done. As these elements are there, that will be printing on your output screen. Next comparison with your greater than or less than or there. Greater the elements are there. Whenever the lesser the elements are there, exchange will be done. Greater the element is there, pushed as it is. 12 after your 10. Same. No exchange. Here also 2, 20, 12, 10, 15 and your 2 is there. Again your lesser the value is not there. Is there. Then no exchange. As it is your 10 and your 15 is there. Now next alteration which is a comparison between your checking with your 2 is the smallest index is there. I want to be swap or not, it is going to be checking with your current minimum value. That is your minimum value is going to be stated with your the starting element of the index with your last index of elements. That is going to be selecting. That is 1 is to be 2 is to be positioning on the 0th index and 20 is to be the last element I want to be positioning into the 20. Then I want to be performing the swapping procedure here. Like that, which element I want to be swap that into the current position, I can best choose with your selection sort environment, which is not having that lesser than or greater than, but I want to be position that this value to be exchanged to the starting index. Then I am going to be swapping the procedure. Here also we are taking the comparison of the two elements together. Two elements together to the comparisons. That's why your time complexity is taken with your n square 2. Clear? And your space complexity, only one element is going to be exchanging and taken into space is your one element finally is going to be exchanging the environment. That is your selection sort. Coming to the next one, insertion sort. It is also same, no need of your taking the unsorted elements, sorted elements, ascending order, descending order, but I want to be place that one element to the existing positions by performing the iterations. Means this places your unsorted elements in a suitable place. I want to be place it. No need of checking that lesser or greater than, just I want to be position the places. Just inserting the already existing list, new element or that element I want to be exchange the positions. That is simply same algorithm we are done in your selection sort. That is the same procedure we are going to be checking here. And that I want to be perform that. The 5 has to be exchanged with that. Mainly we are going to be checking with your indexing to be map and exchanging can be done from the initial position to the current position. That is your finally output is. Here also 2 elements I am going to be associating. N square I am taking the time complexity. One element is only the positioning. The space complexity is taken is your 1. That is your insertion sort. Next coming to the merge sort. This is a final sort we are going to be seeing in your sorting algorithm. Here the one sort, one of the most popular algorithm is your merge sort on your making the data organization in the format of the function declaration. Like what we are going to be discussing the function declaration like is nothing but functions are foremost declared like a block environment. I have the complex program is there which is having the plenty instructions are there. I want to be make the solution of that complex program. Then it is taking a lot of time for the evaluation process. What can I do? The procedure is nothing but I can take the functions into the nature, dividing my complex programming into the simple dividing of your blocks, and each and individual block is going to be evaluated separately. Finally, their associated solutions are going to be combined together to get the final result. Like that, the efficiency also I can decrease, time also I can decrease. Finally, within the short time, I can evaluate my programming concept of complex evaluations. Like the same concept, we are going to be taken into the consideration of algorithm nature. The merge sort is the best solution for that to make the complex problem in faster the calibrations. See it. That is your one procedure we have taken, same like your function concepts. We had your divide and conquer algorithm. That is your seeing the picture, we can easily predict that how the divide and conquer method is going to be performing for finding the final solution. That is, we have the array of the elements 6, 5, 12, 10, 9, 1 is there. We have the array indexings of 0, 1, 2, 3, 4, 5 indexes I take it. 6 elements I have taken into consideration. But my final intention is nothing but all the elements to be arranged in the ascending order. The final solution is how I am going to be performing with your divide and conquer method. See, seeing with your element association, I am taking your merge sort of your array elements, which we are A declares your array elements, P declares your left elements, R declares your right elements. The right elements, left elements are nothing but this. How I am dividing into the half, which is going to be predicting your left elements. LE I am writing. This is your right elements, which is I have taken 10, 9, 1 as your right elements association. This is your dividing procedure. After dividing, I need to be divide that all the array elements in your individual fashions. Like your 6, I am going to be from your left array. See, I am dividing into 6 and your 5 and 12. And again I am dividing your 5, 6, 5 and your 12 separately. Like you're dividing the each array or group of elements in your individual fashions. Then you associate in your ascending fashion. Now 6 as this, next you are combine your 5 and 12, you are divided and you are combined together. When you are combining, we are going to be taking with your, which is the lesser than was there, move to the left order fashion. And make your 6 into the middle order of your elements. Make your 12 as your last element of your order of your left element association. Same fashion we are done with your 10, 9 also, 1. See, 10 I am divided, 9 and 1 I am going to be dividing your left side. 10 is your right side, again to the right of your left I am taken with your 9 and 1. Right of your left again evaluated in your 9 and 1. Then I can combine after whenever I am combining, check the comparison whether is your lesser than or greater than, make the association lesser than your left side, greater than on your right side of your 9 element. Now combine again. Whenever combining together 10, 1, 9, again see the association. Left side of your 10 element is going to be having the greater element, position that into the right side of your right element as it is greater than your 1 and 9. Then those are going to be combined into together. Like that, though both our elements are going to be associated whenever you are combining these two, check the comparison, the elements which is there inside of that 5, 6, 12 and 1, 9, 10. And now swap the procedures with your lesser than the left side, greater than the right side we are going to add with. Like that, we are taken with your 9 of your right side with your left association. Then your left of your 5 is going to be associated on your next indexing. Like that, your 1, 5, 6 from your left side we are taken, 9 on your right side you are taken, then your 10 on your right side you are taken, and your 12 on your left side you are taken into the association. Finally, my merging is done. This is your, this procedure we are going to, from here to here, we are going to be calling your dividing the procedure. And from here to here, we are going to be conquer the procedure we are going to be calling. That is your combining. Conquer means nothing but we can call it as combining the elements together. Like that, your elements are going to be checking the comparison here, return with your dividing the procedures. Next, we are going to be combining the conquer method with these elements, with these algorithm procedures. Finally, my merging of your array elements are associated here. The time complexity taken for your each and every element on your dividing the procedure, we are taken with your number of elements up to the individual we are dividing. Like that, your time complexity plays your O of n log n procedure we are going to be performing. And the space complexity elements we are, how many elements we are associated initially, same element space we are taken into the last output also. That's why no variation in the space, we are taken here O of big O notation of your one element association for the space allocation we are done. This is your merge sort procedure. That's why it is called your best procedure to be performing the ascending order, as it is lengthier but the faster in the calculation, and very effectively we are going to be pushing into the output screen. Clear? With this, we are completely the sorting procedure of the array operation, finally organizing our data in your particular algorithm environments and framing the data structures together. Thank you.